Hello everybody, and welcome to the second video of the course. In this video we'll be doing an introduction to what are called conditional statements. So the goal of this video is to introduce Python's if, else if, else if, else structure. This will become clear as I introduce it, and then introduce one more piece of arithmetic, the percentage operation. This is another operation like addition, subtraction, multiplication, etc. that might be useful as we move through the course. So I'll introduce both of these things through examples. So just to motivate the if, else, if structure in Python, consider this program from last time. So let me just reset this. You're taking a course, and the final grade is based off of 3 data points. There are 2 exams and a final exam. Each exam is worth a quarter, and the final is worth half. Write a program that calculates your final grade. This is a program we did in the previous video. So now, in this video, consider something like this. Suppose that you're taking the course pass-fail, where pass means that you get a final grade of 70% or higher, and then a fail, of course, would mean getting less than 70%. What we would like to do is get the program to print to the screen either pass or fail, depending on what kind of grade you get. Okay? So now the program is not going to just print, or merely print, your final grade. We also want the program to be able to tell you whether you have passed or failed. So what kind of schematic would that look like? I mean, what kind of thing would you need to do that? Well, you need what are called conditional statements, or if statements is another way to say that quickly. So what's sort of a schematic of how you can get this task done? Well, you can take the program we already had, this program that calculates a final grade, and then we need to add something like this to the code. Okay? So this is not Python here. This is just sort of a little schematic. But if the final grade is 70 or higher, the program should print pass, because we passed. Otherwise, though, it should print fail. In other words, we need to teach the computer how to take 2 possible separate paths, okay? The program is not going to print both pass and fail, because you can't pass and fail a course. It prints one or the other. There are sort of 2 branches the program could go down right here, the pass branch or the fail branch. We have to tell it how to handle that. So before making things more formal, let me just quickly show you how this exact program works. And as in the previous video, I will be jumping from slides to the coding environment here in Anaconda. So I already have Spider fired up here, and I already have the previous program from last time on the screen here. This is the program that calculates a final score and then prints it. So as I mentioned last time, if I were you, I would be following along in your own compiler with this video. So either you are watching this video in the computer lab, or you're watching this video on your laptop and you have Anaconda installed on the laptop. Okay, it's better for you to follow along with the code yourself rather than just watching me do it. And then you can make tweaks yourself. You can make changes to the code yourself and sort of experiment with it and play around with it. Okay, so anyway, here's the program from last time. Let me just run this. Oh, I haven't saved this yet, so I'll just throw it on the desktop. So now it's saved. Okay, so I ran it with an exam 1 score of 75, exam 2 score of 90, and a final exam score of 95. My final grade is like an 89. Okay, so that's not bad. Anyway, that's what we did last time. So now if we want to do this pass-fail thing, let me just now add a new line of code. So what was the schematic? If my final score is 70 or higher, so greater than or equal to 70. So in Python, greater than or equal is written like this. The greater than symbol followed by an equals. Then you put a colon at the end of that. So if you read that in English, it's saying if this final score is at least 70 or higher, well then we need to teach the program to print the phrase pass. And notice my cursor was up here. When I hit enter, it indented. Okay, now the cursor is underneath the if and it's shoved over to the right a little bit. And then there I'm going to write pass. Okay, so here's our first introduction to where Python indents code for you. So the fact that this is indented, and it's indented underneath this if, that means that if this condition is true, So if my final score is indeed 70 or higher, I'm going to do what's under the if, what's indented underneath it, okay? So if the final score is 70 or higher, I'm going to print pass. Otherwise, I could fail, right? And so otherwise in Python, the word is else. Okay, so if my final score is 70 or higher, print a pass. Otherwise, and now notice this else, it's not indented. It's sort of on the same hierarchical level as the if. So if this thing, then do this, print pass. Otherwise, right, this otherwise is on the same hierarchical level as the if. They're sort of equivalent. Otherwise, I would want to print fail. Okay, that's how like the schematic from the slides works. This is how you can tell it, do this or this, right? If my score is 70 or higher, do this. Otherwise, or else, do this. So if I run this now, what happens is it calculates my grade as an 88.75, and it tells me I passed, you know? Okay, so just to summarize here, this little structure right here, it gave the program two possible paths to go down. It could either tell me I passed, or it could tell me I failed. It couldn't tell me both, you know? So now, after this is done, after your if-else structure is done, if I come down here and start telling it to do more things, let me just run this and show you what happens. It prints my final score, which is like an 89. I passed, and then since it went down this branch here, it went down the pass branch, it doesn't even do this. It doesn't even see this else thing, okay? So then, in terms of what the program does when it reads from top to bottom, now the program is right here at line 20. There's nothing there, so then it moves on to line 21. So this is our first example of an if-else structure here. You basically, between lines 16 and 19, you're giving the program two options for what it could do. It could either print pass or fail. It chooses one of those options based on this condition here, and then when it's done with that consideration, it just keeps moving on through the program. Okay, so that's how like an if-else structure works. Okay, so let me just come back to the slides now. So we've now taken this English and made it Python, like I did in the compiler. Okay, so here's all the the Python translations of English. We just did greater than or equal to with the greater than sign and then the equals. Here's less than or equal to, less than, greater than. Equals, notice, is a double equals, okay? So you don't just write equals, you write two equals. So I'll explain why in a second. And then if you want to write the phrase not equals, it's an exclamation mark followed by an equal sign. Okay, so let me come back here to the program. And let me, for now, just get rid of all of this. Okay, so suppose I write a statement like this. X equals 8. Okay, this equals here, as we discussed last time, is an assignment equals. You are creating a variable, a container in memory called x, and you are asserting that x has value 8. You are telling the computer that x is 8. That is a command, okay? Now, if you're inside an if statement and you want to write equals, like suppose you want to check whether or not x has value 9. So whatever, right? You do something like this. Okay, so if x equals 9, then do something, right, is what's happening here. This equals here is not an assignment equals. It's not a command. This equals is like a question, you know. Is x equal to 9? Because if it is, I want you to do something. But if it's not equal to 9, then I guess you don't do anything, you know. So here, in the code here, you're basically forcing the computer to ask a question. Is x equals to 9? And if so, do something. At this point in the code, you are not asking the computer to think about anything. You are just telling it that x has value 8. So if I do this little structure like I had before, you can make it do whatever you want. Okay, if I run this, when the computer gets to this spot, it asks itself, is x equal to 9 or not? If x is 9, it will tell you x is 9. Otherwise, it will tell you that x is not 9. And it tells me x is not 9. Okay? So anyway, that's the difference between two equal signs and an equal sign. Equal signs like this, double equals, show up inside of a question like this. You know, does x equal 9 or not? A single equal shows up like this, where you are asserting something. Before I move on from this example, I should point out that inside of like an if, this is indented here, you can put more stuff. So I'm going to do like this. Like you can just keep telling it to do things. 5 plus 7, whatever, right? Underneath an if, you can write all sorts of commands. So let me just change the x to 9 so that x does indeed equal 9. And now when I run this, it tells me x is 9. And then it just moves on to the next line. It tells me hi. Then it moves on to the next line. It tells me that I'm showing 12 for whatever reason, you know. So inside of an if, you can put whatever you want down there. You can have it print more than one thing. You can have it do more than one command. Okay. So here's all the language you would use. The Python translations of English like, not equals, or equals inside of an if. Okay, so now let's move on to a bigger structure called if, else, if, else. So if, and then else, if, else. It looks like this. So in the previous example, we had a couple of different paths the program could go down. It could either print pass or fail. But of course, in general, you might have more than 2 paths you might want the computer to go down. So maybe you want to print like, oh, if I got an A versus got a B versus got a C versus got a D, and so on, you know. So if you're trying to just print letter grades with no pluses or minuses, there are now 5 possible paths the computer could go down. So if you want to give the computer more options, like, hey, maybe do this, or this, or this, or this, right? A bunch of distinct different options, like an A or B or C, you structure it like this. If, else, and then so on, as many as you want. So let me just show you this syntax over in the program. So let me clear this out. Okay, so x is 9. But x is just some numeric variable, doesn't matter its value right now. Suppose you want to think about, you know, if x is bigger than or equal to 15, then print something. I'm just going to put dummy commands in here, okay, because it doesn't matter for now. But if x is 15 or higher, I'm going to tell it to print the number 1. Now suppose you also want to check else if x is like bigger or equal to 12, just whatever, some other condition. You want it to print maybe 2 or something. Just whatever. Okay, now you're basically giving the computer 2 possible paths so far. If x is 15 or bigger, it could print 1. If x is 12 or bigger, it could print 2. Notice though there's a little red symbol right there. It doesn't like that. So in Python, the English phrase else if becomes condensed to elif, like that, just E-L-I-F. Okay, so what you're saying in English is, well, if x is 15 or bigger, do this. Print the number 1. Otherwise, if x is 12 or bigger, print 2. You can just keep doing this. Otherwise, if x is like bigger or equal to 8, print 3. Otherwise, if x is bigger or equal to 5, print 4. You can just keep doing this. Otherwise, if x is bigger to 1, print 1, and then whatever. Oops, sorry, not 1, print 5. Keep my numbers going up. This. Okay. So here in all of its glory is an if, else if, else if, else if, else if, else statement. Okay, so what is happening here? We have given the program, when it reaches line 11 right here, we have given it 6 possible paths it could go down. It could either print a 1, or a 2, or a 3, or a 4, or a 5, or a 6. The computer will start reading, or the program will read from top to bottom. First, it will check if x is 15 or bigger. This x is not, okay? So it's not going to print 1. It will then move on. It will check, is x 12 or bigger? If that's the case, it will print 2. But x is not 12 or bigger, so it won't. Then it will check if x is 8 or bigger. And if x is 9, that is indeed the case. Okay, so it will print 3. So as it reads from top to bottom, finally it got a hit. This was actually true. Then what will happen is, after it prints the 3, the program will just jump all the way down to the end of this entire structure. Okay, the program only goes down one path. It will not go down multiple paths. So notice, right, x is also 5 or bigger. That's true. But it's not going to go down this path. It won't print 4 because it only goes down one path. So if I run this, it prints a 3 over here and only a 3. Okay, because it doesn't see this x bigger than or equal to 5, or this x bigger than or equal to 1. So when you set up a structure like this, I have now given the computer 6 possible paths to go down. It can only go down one of them. So now if I do x equal to 20, okay, 20 is bigger or equal to 15. So it will print 1, and then it will just stop. It will just jump all the way down to line 23. So suppose at line 24 I put, hello or whatever. It will print my number 1, then it jumps all the way down here, just skips all the rest, and then it prints hello. It just keeps going. It doesn't see the rest of this. Okay, so that's how an if, otherwise if structure works. The last thing I should say is when you write else or otherwise in English, this is just a catch-all thing at the end. So if you haven't gone down one of these 5 paths here, then you must go down the 6th path if you write an else. Notice there's no like condition on this. Like this has a condition, x bigger than or equal to 15. This has a condition, x bigger or equal to 8. This else does not have a condition. It's just a catch-all at the end. And by the way, you aren't required to include that. If I took this out, then let me set the value of x to like 0. The program will check, is x bigger or equal to 15? No, so it doesn't do this. It doesn't print 1. X is not bigger or equal to 12 or 8 or 5 or 1, so it just doesn't do any of the paths. It doesn't print anything. It just prints this hello from down below. Okay, so sometimes, like what here, I've given it 5 possible paths to go down, but it didn't like any of them, so it didn't go down any of them. So when you set up an if, else if structure like this, if you don't include the else at the end, maybe it doesn't go down any path, okay? But at the very least, it only goes down one path. It cannot go down multiple paths when you have a structure like this. Okay, so this is an introduction to conditionals, to if statements. We will come back to this throughout the course, but at the very least, we have the basic structure in place. Okay, so if you're thinking about like what kind of quiz question might you see when you first show up at the beginning of class, here's the kind of thing you might see. A structure like this. This is basically just what I had in the compiler, right? X is equal 10. So this doesn't happen, but this does happen, right? You get a hit. 10 is indeed bigger or equal to 10, so it will print hello to you. And now, even though 10 is bigger than 3, it won't do this. It won't print there because it already did one of the paths. Okay, so let me conclude now with a new operation of arithmetic. Let me quickly finish with this. This is something like addition, multiplication. It's something you can do with numbers. And here's how it works. If a and b are whole numbers, then a percentage b is the remainder when you divide a by b. Okay, so it's kind of like division, except when you divide two numbers, right, you get that decimal part, if there is a decimal part, and that sort of has the remainder encoded in it. This percentage just picks off the remainder only. So for example, if you divide 7 by 2, 7 divided by 2 is 3 with a remainder of 1. So since the remainder is 1, that's all the percentage symbol cares about. It just picks off that 1. If you divide 6 by 3, you get 2 with a remainder of 0. So the percentage just picks off that 0. When you divide 9 by 5, you get 1, because 5 only goes into 9 once, with a remainder of 4. So the percentage symbol picks off that 4. So why is this useful? Well, one observation you can make is that a percentage b equals 0 if and only if a is a multiple of b. Like in this example here. 6 was a multiple of 3, so 3 just goes into 6, with no remainder. 9, though, was not a multiple of 5. So you actually had something non-zero over here. 7 was not a multiple of 2. So you had something non-zero there. Okay, so let's just write a program that tells us whether or not a number is even, and that will be the end of this video. So let me come back over here. So I've got my number up top, give it some dummy value at first. The number is 9, okay? So we need something like this. If number is even, then like print even. Else, like otherwise, right, if it's not even, then print odd. That's what we need. Now, of course, this is English, what I've typed here. There's a lot of English here, right? If my number is even, Python doesn't understand that, because Python doesn't understand that raw English. So the question is, in this if statement, how do I tell it whether or not my number is even? What would that even mean? Okay, well, recall, a number is even if and only if it's a multiple of 2. All right, so 4, 6, 8, 10, numbers like that are multiples of 2. And also recall, right, we now have this observation. You can tell if something's a multiple of anything. So if you make b be a 2 right there, so a percentage 2 is 0 if and only if a is a multiple of 2. So in other words, multiplicity like this, testing whether or not a number is a multiple of 2, you can test it with that percentage symbol. So let me come back over here. If number, I already have that, if number percentage 2 is 0, and I have to use the double equals here, right, because I'm in an if. I mentioned that from a previous slide, right? So anyway, if I take my number and I divide it by 2, and my remainder is 0, the number is even. Otherwise, the number is odd. So if I run this, since number has value 9 right now, notice it tells me odd. Right? 9 is an odd number. It wasn't a multiple of 2, so it didn't do this print. It jumped to this one. If I change this to like a 16 or something, though, it tells me even. Because when I take 16 and I divide it by 2, I get 8 with 0 remainder. Right? That's what it means to be even. So it will print even. Okay, so at the end of this video, you now have a basic understanding of how conditionals work, how you can check if, otherwise sorts of statements in English, and you now know what this percentage operation does. We'll be returning to these topics throughout the course. This is not the last word on these topics by any means, but we at least have an introductory understanding of those two topics in Python.